So now we agree that higher IRR is for a better project. So the cutoff point here is the cost of capital. If IRR is greater than WACC, or weighted average cost of capital, then we should accept the project. Otherwise, we reject the project. In the previous example, we showed that the WACC was 10%. If IRR is greater than 10%, we accept it, or we accept any project that has a higher than 10% IRR. If the projects are mutually exclusive rather than being independent from each other, then we just pick the one with the highest IRR. And if we move back to the example I showed you, right here, your WACC is 10%, and if your IRR is 10%, right here, that basically says your cash flow is 110 in the next year. And in that case, your NPV is 0. Okay, so with the discount rate of the WACC. Okay, so but if your IRR, let's say, is 20%, that basically means it would be 120 for the next year's cash flow. Okay, and then you would have a positive NPV, so that's good, or you have more money to make in the next year. Alright, so the bottom line is we want to compare our IRR against the WACC. So if IRR is greater than WACC, we accept it. If IRR is less than WACC, we reject the project. Okay, and also you can tell that the WACC and IRR always lead to the same accepted reject decision for any given independent project. So that means if we just consider only one project, so the higher discount rate you put in there, then the lower NPV you would get. Okay, and if you have a higher IRR, that also means you have more cash to make in the future, so the better the project is. Okay, and if you look at this curve, NPV goes downward as the discount rate goes up. Okay, from left to right, the discount rate goes up, and NPV reach to the bottom 0. That's a break-even point at the IRR. So when the discount rate is your internal rate of return, your NPV is down to 0, following its definition. And before that, if the IRR is lower than the WACC, then you should have a positive. If IRR is greater than the WACC, you should have a positive NPV. So right here is where your discount rate, your cost of capital is your discount rate. So you have a low discount rate or low cost of capital that is lower than IRR, and you have a positive NPV, so you accept the project. And right here we're talking about this side of the curve, so that's when the cost of capital is greater than your cutoff point of IRR, you reject the project. Okay, but what about if you have two projects that are not that are mutually exclusive from one another? You want to choose the better one. Okay, you have two projects, L and S. You want to choose only one of them. Okay, definitely you want to choose the one with higher NPV or higher IRR. And if you look at these two cash flows, you will see that project S gives a higher IRR. Okay, so you can verify that using your calculator. So for the time being, for practice purpose, I'm going to use this calculator to show you again how to do that kind of practice. Okay, how to calculate the IRR like that. So what you do here is you hit apps, and then you hit finance. Okay, then number 7. Oh, oops, sorry, number 8. Apps, finance, then number 8 for IRR. Oh, I should clear that. Okay, so let me just start over again. Apps, finance, number 8. Okay, and then you put your cash flows starting with cash flow 0, negative 100, comma, and then you need to put a brace, which is a second parenthesis, and then you put 70, comma, 50, comma, 20, and then you can just directly hit enter without closing the parenthesis and the brace. Alright, and then 23.56. You can do the same thing with the project L, so your IRR would be 18.1. Okay, based on the IRR, you would choose project S, that's for sure. However, if you use NPV as the criteria to make judgment to see which one is better, you would reach different conclusion. And here is when you have different discount rate. Okay, you have a different WACC. Then for both projects, the NPV would decline as the discount rate increases. Okay. However, if you your WACC reaches to a certain level, then your comparison would alter. For example, if WACC is between 0 and 5, then at lower range, then the NPV for L is greater than the NPV for S. If WACC increases to 10% to 25%, then the NPV of L is less. Okay, now the situation has changed. The NPV of L is less than the NPV for S. Okay, so if you put the curve on the chart for the two projects, so this is for L and this is for S. Okay, so let me just show you the animation. Okay, so this is for project S, and the project S has higher IRR. As you can see, the cutoff point with the horizontal axis is more further to the right. Okay, and the project L is like this. It has a lower IRR. But the thing is, if your WACC is at a lower range, okay, is at this part, then project L is better in terms of NPV, and the project S is worse. Okay, and if your WACC is greater, then the project S is better than L. Okay, so you should know that here is where the two projects, the two curves intercept with each other, and that is called a crossover rate. Okay, and you should be able to solve this crossover rate. Okay, the crossover rate in this case is 8.7. And if the WACC or the discount rate is less than the crossover rate, you accept the project with the lower IRR, which is the project L. If the project with a higher with a higher discount rate, you would accept the project with higher IRR. Okay, so just to be aware, there could be conflict between the decision of using IRR and the decision of using NPV. Okay, because when you use the NPV to choose the project, the decision may depend on the value of your discount rate. Okay, so how do you solve for this crossover rate? These are the cash flows for the two projects. So the crossover rate is very easy to get. You just find the difference of the two cash flows. Okay, you will get a incremental cash flows from L to S. It does not matter if you use L minus S or S minus L. As long as you get the price difference, that's good. Okay, and then you will solve. Okay, so this is the difference. Then you will solve the IRR based on the cash flow difference. Okay, so use -100 minus -100 gets 0, 10 minus 70, -60, 60 minus 50, that's 10, 80 minus 20, that's 60. Then you get IRR based on these cash flows. Okay, and if you use your calculator or your Excel, that should be your answer, 8.68%. And this is a required skill for your exam. Okay, so if you use your calculator, this is how you do it. Okay, so you have apps, finance, number 8. Okay, then you put a 0, comma, alright, and then race, then you put a -60, comma, 10, comma, oops, what would the answer? And then +60. Okay, hit enter. So 6.1 8.68%. Okay, or if you use Excel to do the job, that's also pretty simple. So you have a 0, negative 60, 10, 60. Okay, so use IRR to do the job. Okay, so this is 8.68%. All right. So the implication here, as I said earlier, if you have two mutually exclusive projects, you can only choose one out of the two. Your decision really depends on the value of WACC. If the WACC is less than the crossover rate, you accept the one with a smaller IRR, and if WACC is greater than the crossover rate, you accept the project with bigger IRR. And the crossover rate is given; it's determined by the cash flows. So that is already a set up number. Okay, so now let's talk about the pitfalls of using IRR. I just showed you that sometimes there's a conflict between the decision of using IRR and NPV. Okay, and some other shortcomings of using this IRR method is sometimes it does not distinguish between investing and borrowing. Okay, and sometimes you may have a multiple IRR or even does not have IRR at all. Okay, so if you look at these two projects, project A is for lending. You get money first, and then you deposit money first, and then you receive money later. So you would have a positive 50% IRR. Project B is about borrowing. You get money first, and then you pay out money next, so you also get an IRR of positive 50%. Okay, so you have the same IRR no matter for lending or borrowing, but if you look at the NPV with a 10% cost of capital rate, then you would have a quite different answer. All right, and next, if you look at this cash flow, all right, let me just use Excel to demonstrate that. So in Excel, let me just give you this cash flow. So you have negative 100, 230, negative 120, 132. Okay, so negative 100, 230, and negative 132. Okay, so if you use a 10% as the discount rate, you would get 0 IRR. Okay, so let's say NPV of 10%. Okay, and then you choose these two future cash flows, and then plus this one, you get a 0 NPV. Okay, you would get a 0 NPV. All right, and if I use 20% as a discount rate, okay, and then I will still get 0 NPV. You see, no matter if I use 10% or 20%, I always get I got a NPV of 0. Alright, so that basically means I have two IRRs. One is at 10%, another is at 20%. So that's pretty weird. Okay, this is the curve, the NPV curve across the discount rate. Alright, and if you look at this cash flow, you just don't have an IRR at all. So you see cash flow 0 is positive 100. Cash flow 1 is negative 200, cash flow 2 is positive 150. Okay, so if you use 10% as discount rate, your NPV is a positive 42. But if you try to solve for IRR, your calculator would give you a error, and also you would not get an answer from your from Excel. Okay, and the NPV curve is like this. You can see that this curve never intercepts with the horizontal axis, so it will not reach down to 0, so you will not have an IRR by its definition. Okay, and sometimes it's better to use IRR. If you look at the project A and the project B, they both give the same NPV. Okay, so just look at the NPV, which at 8% discount rate, there is just not much difference. Okay, but you should know that project A is better and more efficient. Just to look at the scales of their cash flow. These are all in $1,000 okay, and you still get a $1,400 NPV, whereas for project B, everything, all the cash flows are in millions of dollars scale, but you still get $1,400 profit for NPV. That's very pathetic for project B. Okay, so that difference would be reflected in IRR. For project A, IRR is better as it has higher efficiency of making profit, and for project B is lower. Okay,